So how come running Postgres in Kubernetes went from no way to the way? And what role CloudNativePG, sorry, this is not working. What role did CloudNativePG and EDB, my company, played in this transformation? And most importantly, what is our vision? What is the future looking for running Postgres in Kubernetes? So welcome everyone. Thanks for joining me tonight. Here it's a pleasure to be in Sydney in this Amazon AWS building, and I want to thank Kubernetes KSUG.AI. I still don't know how to pronounce it, but for having me. And I want also to thank EDB for sponsoring this event. So tonight, I will be talking about the past, the present, and the future of running Postgres in Kubernetes. My name is Gabriele Bartolini. I'm, as Ram pointed out before, I'm VP and Chief Architect for Kubernetes at EDB. I've been using Postgres for 25 years, and I have also an entrepreneurial past, as co-founder of Second Quadrant, which is a Postgres services company founded in 2008 and acquired by EDB in 2020. So since then, I'm part of EDB. I'm officially a Postgres contributor, and I'm also a Data on Kubernetes ambassador. So the goal is to promote the usage of stateful workloads in Kubernetes. So stateful workloads are in contrast with stateless workloads. So stateless applications are the applications that don't store any state, so they can be restarted and they start from scratch. Applications with state, so stateful, they have a state that is stored persistently on disk. I'm a DevOps evangelist, so I really believe in DevOps, and DevOps is the reason why I met Kubernetes and the reason why I will leave Kubernetes one day. In the Postgres community, I'm known also as the Barman guy. Barman is an open source backup and recovery manager. There's a bit of echo. Can you? Maybe it's too loud. Okay, and it's a backup and recovery manager. It's an open source, one of the most popular tools for that. And now since 2022, I'm very happy to be a maintainer of CloudNativePG, which is an open source operator for Postgres and the focus of this presentation. Let me tell you a bit about EDB, who's proudly supporting this event. How many of you have heard of EDB, except the people that work for EDB? So, Felix, you raised your hand. Nothing else, nobody else. So that's good. So, but how many of you know Postgres? Have you ever heard of Postgres, PostgreSQL? So you probably don't know that Postgres, about 35% of the source code of Postgres has been contributed by EDB in the history of Postgres. So when you use Postgres, many features have been developed by people that have been working for EDB. So we're really happy to work in the open source world, but as you know, open source software is free, but all of us have families and we need to be paid. Okay, so we need to create a virtuous and sustainable cycle. So EDB is a company that also provides not only services but products based on the open source Postgres with forks like a compatibility layer for Oracle that helps migrate from Oracle to Postgres. Since 2022, and given this is a Kubernetes space, we are also known as Kubernetes certified service providers, but most importantly as the creators of CloudNativePG. So we're talking about Postgres. So briefly, is a relational database, is extensible. It's 100% open source. It's used in production and in mission critical environments everywhere in the world. It's very stable. and robust. And even according to the latest survey from Stack Overflow 2 weeks ago, it was declared the most used database in the world by developers. It is important when we consider Kubernetes to understand that Postgres has a very solid replication system. So normally in Kubernetes, when you have a stateful workloads, you use the storage level to replicate data across nodes and achieve data redundancy. And this is annoying. Sorry. I'll shut this down. And let's try this. Okay. So we will use, so instead of relying on the storage level to synchronize the state across nodes, we rely on Postgres. Okay, Postgres has got this feature called host standby, and it's been used, for many, many years. I just want to show you this patch that you can actually see my name here. It's host standby, and it's a feature that was developed in 2009 in Postgres, and has the possibility to query read the replicas for read operations. So Postgres is important to understand that it's a single primary multiple replicas architecture, and replicas can be read. So you can distribute reads, but you cannot scale horizontally writes, which is not a problem. Okay, this is clear. Everyone comes and says, I need horizontal scalability of writes. Not everyone needs that. Okay, there are use cases, but vertical scaling of Postgres can allow you to achieve a very high number of transactions per second with open source Postgres. CloudNativePG, it is important to note that it is now a CNCF sandbox project, and we are aiming to become an incubation project within the next year. We are the first Postgres operator and the first relational database to join since 2018. It's used in production by many adopters. You see some names here: IBM Cloud Pak, Google Cloud, Azure, Bartolini, Hitachi, Novo Nordisk, and so on. For those of you who are not familiar about the maturity levels, this is a slide that shows the sandbox, which is the entry level, and we are targeting, as I was saying, incubation that will allow us to cross the chasm and become a mature project like Kubernetes, which is a graduation part. This is the CNCF landscape, and I applied a filter, so only CNCF projects are listed. And as you can see here, the CloudNativePG is the one of the 5 database projects in the CNCF. So the past, it is important to understand that Kubernetes wasn't born for stateful workloads. Because of the incremental approach that Kubernetes development was done, initially the focus was on stateless applications. And KSUG.AI was the biggest influencer of Kubernetes, used to say this. But then after a few years, he said that what we had actually been saying for many years, running Postgres in Kubernetes is like running it in a VM. Okay. However, first impressions last. So if I take 10 Kubernetes people and I tell them to run Postgres, they look at me and say, what are you talking about? Crazy, we cannot run databases in Kubernetes. That's not true. So that's why I'm, also in these meetups to tell you about alternatives. However, this is what we see pretty much regularly when this has happened in the past. So when you deploy an application in Kubernetes, Kubernetes only contains the applications and the database is outside. So whether it's public cloud like Divas, like RDS, or whether it's VM or bare metal. So CloudNativePG was not the first operator for Kubernetes. There were others, like, for example, Organizers. Okay, like the Crunchy data operator, the Zalando operator. But the most important thing now is that CloudNativePG, which started after local persistent volumes were introduced in Kubernetes, is the only CNCF project for Postgres. Okay? My advice is to try all of them and then make up your mind. But license-wise and also governance-wise, CloudNativePG, by being part of the CNCF, is the natural choice, in my opinion. Also, by the number of stars, that's the most popular. So this is a recap of the Postgres history based on my experience when I started to use it. We would deploy Postgres on bare metal. So we would try and squeeze even more instances of Postgres in the same machines. There was no replication. So you could only take backups. There were snapshots like PG down and similar. Then VMs came out and everyone said, you cannot run Postgres in a VM. You know, you're crazy if you want to run Postgres in a VM. Now you see everyone runs them on VMs. Then infrastructure as a service came out, EC2, everyone started to go in the cloud. But all of these were pretty much day one deployments of Postgres. What changed everything was the introduction of pillars like IDS. So when we started to tackle day two operation, and cloud neutral Postgres, which is what we can achieve now with Kubernetes, Postgres, and CloudNativePG, does exactly that. That provides you with a solution that not only covers day one deployment, but also facilitates day two operations with also automatic reload, backup, observability, and so on. So this is the present. The present tells us that databases are the number one data workload in Kubernetes. Okay, they are fueled by AI. So this is a report if you want to read more. And this is what cloud neutral Postgres means. So you can actually leverage Kubernetes to make your entire infrastructure, including the database, entirely portable. So you're not affected by vendor looking anymore at the cloud service provider level. But if you are, for example, using Postgres in IaaS on, for example, AWS or Google, Azure, and you like the service provider, you can easily move into the Kubernetes offering. Okay. And once you are in Kubernetes, you have already a multi-cloud approach out of the box. So you can easily move from one provider to the other and make your organization more resilient to vendor lock-in. Also, your data, if you run Kubernetes CloudNativePG, will be immediately portable because the solution is compatible with any other Postgres that you have. So you can take your data out, whether you use physical or logical replication. This is very important in Europe, where there's actually a regulation that forces cloud providers to allow you to take your data out from the database as service solution. So if you want to read more, this is an article that I wrote for the CNCF about this topic. The other opportunity that we see is that you can directly deploy Kubernetes on bare metal, so bypass the ballast produced by VMs. So it also reduce the cost. Now that VM costs are increasing, you can bypass those costs by deploying directly Postgres on bare metal Kubernetes nodes. Okay. So this is an option. We see this a lot in Europe, that organizations are going back on-prem. Yeah. So they invest again in bare metal. So briefly, CloudNativePG is founded on 4 pillars. They are the foundational pillars that there's a book, Microservice Databases by Jeff Carpenter and Patrick McFadden. They define a Kubernetes native database based on these 4 pillars. CloudNativePG is defined on those pillars. One is that it's seamlessly integrated with the Kubernetes API server. So if there's something that the API server does or Kubernetes does, we delegate to them. But we also integrate directly by extending the controller of Kubernetes to understand how a Postgres primary standby cluster works. It's entirely declarative. We follow convention over configuration. There's an observability out of the box. So we have a Prometheus supporter. We output logs in JSON instead of output, and it's secure by default. So by default, we take decisions about how to reduce the risk of attacks. For example, with MTLS certificates out of the box, and no super user access by default. So these are some of the major features of the operator. Of course, the most important one is self-healing and high availability. So if there's a problem on the primary, the operator immediately reacts and promotes a standby. So there's support for synchronous replication, so that if you want a transaction to be written also on another node before the control is returned to the application, you can do it even at transaction level. And this is how a Postgres cluster resource looks like. We can define this cluster, I call it Clapton, with 3 instances. I define the affinity rules. So I say, please deploy these on nodes with the Postgres label. And then I request a synchronous cluster where at least one replica is part of the forum. And I request 2 volumes, one for storage and one for write-ahead logs, the transaction logs, using the default storage class. And this is what happens. Because CloudNativePG doesn't use stateful sets, but directly manages PVCs. What happens is that first we initialize the primary PVC, then we start the pod. Postgres starts, it is up, the readiness probe active, the read-write service is immediately available to applications that can connect. Then in the background, we start building the first replica, and then a second. And then at the same time, we also have the read-only service and the read service that points to all of it. So for example, if you want to direct your applications to any replica, you can point to the read-only service. And if there's a problem, let's say on the primary, so the primary goes down, Kubernetes immediately detects it because we have liveness probes, readiness probes that immediately communicate that back to Postgres, to Kubernetes. The operator detects that and promotes the most aligned standby, which becomes a primary. So the read-write service changes the endpoint. It's important to note that applications don't need to change any IP or any host name, anything. They are transparently redirected to the new primary. Of course, they need to reconnect because the connection went down, but this is a minimal issue. And when the older primary comes back up, it is demoted and automatically resynchronized as a standby. So what we are seeing now, so this is the most used scenario for CloudNativePG. We see that organizations deploy the application and the database, sorry, either in the same Kubernetes cluster, but in a different namespace, or in a different Kubernetes cluster. Okay, so they don't deploy application and database next to each other, but they have a separation. So maybe we see often, for example, a completely different Kubernetes cluster dedicated to database. And that reflects actually the organizational structure. So that if there's a strong DBA infrastructure team that doesn't communicate well with the developers, they create different infrastructures. This is always low. Okay. So, and this is another important architecture that you can create with the operator over two different data centers, sorry, regions, so Kubernetes clusters. Because the operator can work in the same Kubernetes cluster, but then outside, we use Postgres replication either in streaming, which is the blue arrow on the top, or via backups. So this is continuous backup here in place to synchronize the state. This is a very robust solution that provides you with almost zero RTO within the same region. So if a Postgres primary goes down normally, in a few seconds, the standby is promoted. So this is a recovery time. And RPO by default is maximum 5 minutes. So RPO is the maximum amount of data you can afford to lose. This is in a single region, and across regions, RTO unfortunately needs to be manual, because you can have an operator on top that coordinates and promotes the other region. But RPO is still roughly 5 minutes maximum. So for an open source solution, this is great. If you want to know more about architectures, there's another blog article for the CNCF here. So the future, this is what we foresee. We try and promote the microservice database approach, which resonates with the Streamline team from Team Topology, which is a very famous book. So the idea is that application and database are live in the same namespace and are managed by the application team that includes also DBAs and Kubernetes experts, either in the team or as platform engineering. Okay. This is another article that explains what the microservice database is, again, if you're interested. So the idea of the microservice database is very simple. It is to shorten the feedback loop between the customer need and the customer satisfaction. Normally, as an enterprise, we try and deliver what customer wants. But sometimes it takes 2 years, 1 year, 6 months, 3 months before we receive the feedback, and that's wrong. With the microservice approach, we have the possibility to reduce this to hours. And I've tried this many times, and this works. Okay, so imagine this: you've got your laptop, you write your own feature for your application on your laptop, and you have your Postgres database as part of your application, and you test that locally with Kind. So use Kind to write your own end-to-end tests. They work. That's it. Good. Submit pull requests. They trigger automation pipelines. And the orange things you see there are DevOps capabilities. So with Git, you've got version control. For example, if you use GitHub pipelines, you've got test automation. Then if you scan your code, scan your images, you've got shift left on security. When you build your container images for your application, and through them, you test the same way in Kind your application. So you've got continuous integration, and you can also test database changes. The good thing of Postgres is that it supports transactional DDL. So you can start a transaction with begin, change tables, introduce fields, columns, add data, and perform a commit at the end. If there's a failure in between, none of the changes gets applied. So your entire atomic change is not applied. Okay? So this is very important. So that allows us to run database change management in the pipelines. If everything passes you manage on the main branch, that's trunk-based development. You can then pursue continuous delivery, and based on your release policy, you can then deploy in production, where the environment is pretty much the same. You have in Kind locally or in Kind in the end-to-end test. So you have no variability of environment end-to-end. This is what allows you to run automatically, even in production, continuous deployment, and achieve, many releases per day. Most importantly, we got feedback immediately and from the end-to-end test and also from the customer. So CloudNativePG for the future, we are targeting, as I was saying, the incubation. So we are interviewing production adopters, and we want to integrate with other CNCF projects like Hotel, Keycloak, and Kyverno, and so on. And we also started the Linux Foundation Mentorship Program. So we are finishing our first program that will deliver foreign data wrappers, which is here, support in 128. So foreign data wrappers is a functionality in Postgres that allows you to connect a Postgres database to another Postgres database or an Oracle database or any other data source in the world. Then we want to improve our declarative role support and make backup and recovery available only via plugins. So make CloudNativePG agnostic for backups. We released yesterday version 127, which introduces, I was talking before with logical decoding slot synchronization, which is important when you are, for example, using all this CDC complex, for example, with division and stuff. So if you've got a failover of the primary, the consumers basically don't use any gas, right? And they can reconnect in this. The extension part is my favorite because you can read in this article, but essentially what happened is that we saw a way to improve the way extensions can be deployed in CloudNativePG, but they require both the change in Kubernetes and the change in Postgres. And we were active in the Postgres one, and we also supported the one in Kubernetes, but this is a patch that introduces for Postgres 18 support for extension control path, which will allow us to mount immutable extension images. So images that contain, for example, just pgvector files. Pgvector is an extension for Postgres that makes it a vector database. And just have pgvector files to be loaded and mounted in a CloudNativePG cluster without building fat images at the start. This is what I was telling you before about the Linux mentorship program, and this is the one that we started. We just started, so we were excited to have 3 more projects. One is house testing, one is to review the documentation, and another one to improve the example project for the CMPGI pluggable infrastructure. So if there's somebody of you who's not working and wants to apply here, it's a 3-month paid mentorship by the CNCF. So to conclude, if you want to move your Postgres database everywhere, into CloudNativePG is very easy. You can use logical version. So for example, in this case, you got RDS as the origin database. You create logical publication. Once you've done that, you create a CloudNativePG cluster. You of course use the same schema. So that database already has the same schema of the original one. You create the cards with subscription, and from that moment, through logical replication, changes are applied continuously to the Kubernetes cluster. When you're ready, you stop your customer from accessing the application there, and then you stop the publication, and then you can synchronize the sequences. This is the only manual step that you need to do, and you can redirect there. That could take, if you program that, few seconds, or maximum, few minutes. Yeah, and this is something you can test and measure before with no risk. This is a blue-green migration, so you can do it multiple times to test if your application works. And then you ditch the other one. So where we're at now is we have the possibility, I believe, with CloudNativePG and Postgres and Kubernetes to start a new S-curve for Postgres. So to make Postgres live longer, this is what I believe. And what I say is that Kubernetes, we think always treats workloads as cattle instead of pets. With Postgres, I say treat them as elephant herds, which is more close to cattle. So we don't need to get too much of attention to any workload, but all we need to do is, for example, dedicate all the working nodes to Postgres. So dedicate working nodes to Postgres, place things, and even use local storage. So treat that especially on the physical layer, but logically they will be treated by Kubernetes itself. So to conclude, Postgres is the most popular database, and I think I showed you how we went from stateless to database being #1 data on Kubernetes workload, then CloudNativePG being the most popular operator, and how we are also pushing the boundaries for both Postgres and Kubernetes. I think the extension stuff is a good example. And right now, if you want to start approaching the project, join the community and try either the internal or external database as a service, which is the most popular use case. It is an important moment because if you're trying to migrate from VMs, you can save a lot of money, even and use that money, for example, to buy bare metal servers on which to deploy Postgres. I showed you, the zero cutover migration and also the microservice database. If you are application developers, I think that's a great opportunity. But in general, the opportunity you have is to be cloud neutral for Postgres as well with this open source stack. So these are my fellow maintainers at mostly the work at EDB. And I want to thank EDB for donating the IP of the project. This is important. It is open source, but the property of the source code is not EDB's. It's the CNCF. Okay, so this is important when you choose the software to know that this is software that is backed by a non-profit organization. So, thank you. I don't know if you have time for it. Yeah, why you can, yeah, Felix.
Yo, question, like, how do you compare, let's say, running using your operator versus the managed database?
So how do you compare for those connected is how do you compare managed databases to the cloud and managed with CloudNativePG? Of course, I mean managed databases they also provide, I think, ad hoc observability set. Okay. But when you move to Kubernetes, you have already made your decision. So it's not that you move to Kubernetes because of Postgres. Your organization needs to be ready to move to Kubernetes. So you need to work with the infrastructure team that has already made decisions about observability. So, so that part is already covered at organization level. When it comes to Postgres, there's really, you need to, in my opinion, you need to understand the bit of Kubernetes as a DBA. And for what I always say, T-shaped profile. So understand you are specializing in databases, but you also need to understand the bit of Kubernetes to have intelligent conversations with Kubernetes. Okay. So once you understand what Kubernetes gives you, once you understand the differences from running the Postgres engine, which is nothing. I mean, it's the same Postgres. Actually, this is the open source Postgres. In the cloud, you don't know. But here you've got the possibility to choose the extensions you want. You have more freedom. You have the possibility to choose which version of Postgres to run. And when to upgrade. All these kind of decisions that are free. But in general, I think the biggest obstacle is if you are using and used to a particular vendor observability stack to move to the observability stack that is more generic for Kubernetes, like could be Grafana, the Grafana dashboards or the alerts. But In the managed solution, they provide all that for you. Here, you might need to, spend some time on configuring that, but once you've done that, it lasts forever. And again, it's something that you take with you forever. When you invest in open source, basically, you remove the vendor lock-in, as I said before, and you also have the possibility to contribute to every project that is part of the Kubernetes landscape. So even organizations have more power to even influence. For example, our customers, when they work with us, they come up with ideas or needs, and we think they're good, and we put them in the open source project. So this is how I think organizations can now influence the future of these technologies now on, and help remove another form of vendor lock-in, which is something that others stress always a lot. So, but in general, from a Postgres point of view, it's the same. So it's really nothing changes. Okay. Questions? Okay, thank you.
Thank you. And next time when I use Postgres, I will remember you because your organization contributed 35% of the code. Thanks for that. Now we can. Yeah. 1 minute. Now I welcome Faisal for his talk. Yep. Thanks, Gabriele.
Thank you very much. All right, well, I think the interesting part, I've written 3 books here. So what we are talking about today is called distributed inferencing. How many of you are running inferencing workload at the moment? All right, so make me sad already. So let's see. So we talk about foundation models. You guys know what foundation models are? Yeah, ChatGPT, Quen, DeepSeek, Gemini Pro, blah blah. So with the foundation models, because they're coming from Americans and they like burgers, right? So they want to be bigger burgers, more layers. So similarly, foundation models when they come, they are becoming more and more heavy. So for example, we started with 200 billion models parameters. Then they released recently 3 quarters, which is 640 billion. And Kimi K2 coming from China is 1 trillion parameters. So if you compare that, one parameter is stored in, let's say, 2 bytes, if you are using the floating point, and it's between 1 billion multiplied by 2 is like 2 billion. So you need like a crap load of RAM to actually load those models. You understand what I'm saying? So what we'll do is the 640 billion model. So as soon as the new models come in, they need more virtual RAM to load and work. That's why NVIDIA stock is going all the way up, right? So we have X100, X200s. It's not stopping because they will generate more hardware with more VRAM, and that will help you load more bigger models. But that's actually present a challenge. Okay, so the first challenge is reducing cost, because when you are inferencing your machine learning or foundation model, if you can get your hold to the latest hardware, please do let me know. I'll be happy to buy it from you, because it's not available to anybody nowadays, right? So if you're looking for H200, it's very difficult to get hold of those hardware. So it's better to, from availability perspective, how about if I can run the model on H100, which is less memory? How I can do that? So I can be remaining in the business, right? Plus H200 is a very, what I would say, is costly, right? So what is the number one aim for running your business? Anybody? Sorry? Make money, right? It's not about customer service. It's not about solving a real world problem. It's just making money, right? Even though it's not too much money, but still, it's still money, right? So what we want to do here is reduce the cost. So how we can reduce the cost? I want to use the latest and the greatest and the fastest model, but I want to reduce the cost. So we'll see how Kubernetes actually enable you doing that. The second topic, as already covered, is improving availability. You cannot get hold of H200 nowadays, or the B thing that is coming very soon. So how about A100s or L4 if you are like running from 2019, right? So those hardware is readily available. The availability of those hardware are more as compared to the latest one. So if I can run my model on lower hardware, that will improve the availability and reduce the cost, right? So I can serve my customers better and keep making money. And the last thing, elasticity, is when you're provisioning a machine, let's say it takes 20 minutes or 30 minutes for the machine to become active. For those 30 minutes, Amazon will still charge, right? But it's not making money for you. So you need to have a system that actually scales faster and better so that you can be consistent with your bills with us. And how many of you actually are gamers? You guys know this black plastic box for it is? Anybody? Yeah, CPU, right? RTX? What does RTX stand for? What is the difference between RTX and RX? Awesome. So they are one of the gamers here. So like you see, like if you are talking about the models, so the models, do they care about red trace? The models are talking about VRAM. And because the VRAM, the difference between the VRAM and the RAM that you get on the Windows PC is the megahertz. How fast you can read and write to them, right? You know why Apple computer is more expensive than Windows? For still go want to make money, that's separate thing, but still they have better hardware. Their memory bus is much better than the DRAM bus on the SoC that you normally end up needing. So that's similar, not similar, in the same ballpark as NVIDIA GPUs, not in the same range, but at least same ballpark. So they put faster. Sorry, faster the memory on iPhone phones is faster. Oh, not Apple SoC. Apple SoCs are better. Faster, yes. Right. So let's see how we can load the models. So again, I want to load the models on lesser hardware, lesser VRAM, right? So there's a concept called pipeline parallelism. So what it does, if you can see on the left hand side, we have three machines. So models are basically layers, just simply, right? So what you can do, what about if I can load my models on different machines, each layer on different machines. Instead of looking for one fat machine that can take all of three layers, I can put three lean machines, which are cheaper and more available, and run my models on them. So that will solve a lot of problems, right? But in software, you say you have to sacrifice something if you are gaining something, right? So what are we sacrificing here? Anybody? So two things. Yeah, say something. Throughput, okay. What else? Come on, you are all computer enthusiasts, right? So very simple diagram. Huh? Network bandwidth. That's a good thing, right? So if you see here, the first thing I want to see here, if you see the machine one processing layer one, then it has to throw the board to the next machine. So network bandwidth can be a problem because you have to connect them with high-speed network, right? If you're running the same machine, it's called IPC or network communication. The other problem you can see from the timeline like diagram is I have machine one, it processes the layer one, and I throw it back to machine two is processing the layer two. Now at that time, machine one is not doing anything. You see what I'm saying? So I'm paying Amazon, but I will take your money anyways, but we want to make sure that you have a system here that actually optimized for a particular problem. Right? There's a couple of problems. So what the community, the open source community does is because I also used to work at Red Hat, so I understand how open source works and how less money you make as an open source. So you can see here is this one of the optimization that comes from open source community is what's called micro batching. So instead of processing the whole layer, we can process a single one, like a smaller batch of your prompt. So think of it as like, for example, let's say your prompts or your tokens are people, and they are the roads, and then you're traveling in the cars. So every prompt has its own location and it's a processor over here, right? How about instead of traveling with the cars, we have a bus that comes as fixed frequency, and we can have more people on the same bus. So we can process more tokens. It's called microbatching. But here you can see here the machines are more kind of bit better utilized. So that's called micro batching. All right, so let's see this. The three problems in that thing is number one is lowest latency. We have to find out how we can communicate the machines with a lower latency. So we can, when we throw the input and output of each layer, that actually gives you a reasonable response for your customers. The second one is very, very important. I think we talked about stateful set before, right? You guys know about stateful set? Come on, you have to say yes, otherwise I'm gonna hand over you, right? We are in a Kubernetes meetup, we need to know at least stateful set. So, okay, so the stateful set is basically our way to scale stateful workloads. For example, Postgres, right? Or Redis or something else, right? But the problem with the stateful workload and this one here is stateful workload you can scale by pod, 1 pod, 2 pod, 3 pod, like this, right? But when you are deploying this model, have you seen the previous picture? I have 3 machines or 3 pods. So when I talk about scaling, I cannot scale 1 pod. I need to consider those 3 pods as one set. Does that understand what I'm saying? So it's called set of a stateful set, basically. You want to make it more complex. So instead of incrementing or scaling per pod, you have to do per set. And there's no such thing in Kubernetes as of now, right? So they have created a new thing for that, which I'll show you quickly. And the last but not least is the responsive elasticity. For example, you want to scale from 3 machines to 6 machines. And imagine if you, instead of going to 3 machines, it looks like 5 minutes to 2 machines and 15 minutes to 3 machines. So those 2 machines will not be useful because it works as a set. So you need to have a responsive elasticity so you can still save cost and perform. So these are the 3 challenges. So the first thing is lowest latency. So if you use Amazon EFA, is Elastic Fabric Adapter. That's actually Amazon's way of lowest latency network. And the latency across 2 machines is 75 microseconds. Google TPU Fabric has also a similar output. So that's like more RPC-like behavior you can get across machines. There's a new thing in Kubernetes called leader worker set. Have you guys heard about that? Okay, it's about to get released, it's not released. You can wait from development branch and run it. So what it does is basically a set of stateful sets. So the stateful set increment by 1 pod, but I want to increment by 3 pods now, 4 pods, and number of pods for my model. So that's a leader worker set. We're gonna go a little bit deeper into that. And third one is we have a thing called Carpenter. Have you heard about Carpenter? So Carpenter is just-in-time scaling. That's one of the few things that's come from Amazon to open source. It's another way. So even Azure is also adopting it for their Kubernetes nodes. So it's getting some traction. It's a really cool open source product. So we can tackle all these 3 things, right? And with all EKS, we can put everything into one single YAML. You don't have to worry about that. That's a lie. You need to understand what you're doing. But still, if you know what you're doing, it's easier for you to adopt. Right? So that's how the benefit of declarative configuration in Kubernetes is you can just define it, do it for you, but you need to understand what you define. All right, so leader worker set is very, very simple. So I have a leader. So let's say I want to deploy a machine learning model across 3 pods, 3 nodes, right? So one will be leader that will distribute the work and orchestrate the work, and 2 will load the models. This is called leader worker set. There's one leader and there are many workers, right? You can do by stateful set today for this one, no problems. But if I want to scale, I want to scale as a set. I will not scale pod by pod. I will scale as a set. So I have 4 written, now I want 8. Because the whole thing actually loads in the model. And that's a problem that leader worker set is solving. It's called set of stateful sets. All right, so if you want to reduce costs, improve availability and elasticity, what we have seen in the wild is if you are running models on managed service providers like Google Gemini, OpenAI, and Bedrock, and if you're on EKS, you can save around 30 to 50% of the cost. Right? But nothing is doing this world, so you don't understand Kubernetes. So that's the only difference you have, right? Improving availability, I'll show you how the leader worker set will help you run your models on lower end machines. You don't need higher machines to load big models. And the last but not least is automatic up and down scaling for Carpenter. So what kind of candidate workloads are? You have real-time inferencing, you have batch processing, or if you are open to use open source models or custom models, or you have a fine-tuning model, then you can use all these categories. Okay. So let me quickly show you a demo, and then we'll take it from there. Any questions up till now here? Anybody? Oh, you can add 4-1, but the model need 3 pods minimum, right? So if you want to scale, you have to add 3 more pods, right? Okay, so let me show you the demo. While I going to the demo, just pray to the demo gods if it works or not. All right, so can you guys see? Can you guys see? Oh yeah, it's better now. Okay, so all right, so let's go to the leader worker set before, or I'll do the. So this is the leader worker set. You can see here. Oh, sorry. Can you see the leader worker set here? So there's a Kubernetes object here. You can see I say right now I need one set of things. One set means 3 pods or 2 pods, whatever, right? I say my leader worker set will have 2 pods in them. It means my model will be loaded on 2 machines. Understand? Some Kubernetes things. Let's forget about pod affinity and all that. So I'm assuming you guys know. I don't think so, but still go ahead. So I have some init containers because you guys don't know stateful sets. So that's not good. All right. So then we have a container that will load my model, right? And in the container, what I'm saying is load the Llama 3.370 billion. Okay. Can you see the model name? So how much memory it will take, just roughly? 80 gig. For example, if you do 1 byte, one parameter is 1 byte hypothetically, then it goes 80 gig, right? So I need an 80 gig VRAM to load this model. Okay. So when you're loading the model, it's not just a VRAM. It's like it uploads the KV caches and it has the prefix caches, but all this gibberish. So you need to have more information, more RAM to make it productive, useful for your customers, right? But what I'm doing here, if you can see here, is I say just load 4 GPUs. Okay, so I'm gonna distribute the model across 4 GPUs. So I'm using a G6D machine, which is L4 GPU. So every GPU is around 20 gigabytes of memory. Okay, so 4 times 20 is around 8 gigabytes. Okay, but I know that I want to distribute the model across 2 machines, right? So if you can see here, what I did here is there's an option called pipeline parallel size. It's number 2. So it means the model will be automatically distributed across 2 nodes. You guys understand? Interesting. How many of you actually, there's a very old Oracle book written by one of the Oracle director, I forgot the name. But he says like whenever he used to talk to customers back in 2005 and 6, they were asking for fast equals true flag. So to make Oracle faster. So customers tell me just tell me where the fast equals true flag is and so there's no fast equals true flag here, right? So but here you can see the pipeline parallelism equals 2. What does it mean is I'm telling my VLM, which is an open source system, that distribute a model across 2 machines. Okay. It has other parameters. Let's forget about that. Then tensor parallel size is across multiple GPUs on the same machine. So I have 4 GPUs. So I put 4 here and times 2 make 8 GPUs. Understand? So that's good. That's easy. I uploaded the EFA adapter, which is the lowest latency one. And the same thing I did for my worker template. Okay. So worker template, I did the same thing. It internally uses a array cluster. You can see here joining the array cluster. And here I'm not need to tell because the leader is defining the whole thing, but I tell how many GPUs the worker will use. So we have a leader and a worker, right? 4 plus 4 is 8, right? So let's take a look quickly. Oops, there are some errors here, so just ignore that. Okay, so I'm running at least one option here, right? You guys can see. How many of you know at least a thing called KEDA? Is okay, good. Anybody else? Okay, good. So KEDA is basically autoscaler, right? So I have an autoscaler object already here, where I'm telling to minimum 1, maximum 5, and then based on the number of requests waiting. So if the number of requests waiting to get processed, it scale up. When it goes down, it scale down. As simple as, right? So this is running over here, right? So let's see if we are actually getting 2 machines, right? So when I run this, you can see here it's running on 2 different machines. one is on, hold on. One is on 108.2.7 and the other one is 15.251. So those pods are distributed across two machines. Okay. Now let's see how many GPUs per pod has, and then we'll see how many GPUs the array cluster thinks it has. So you guys know about NVIDIA SMI utility? It will give you the what GPU is doing inside your machine, just hypothetically, right? So very quickly, so you can see here, I load it into pod number 0, which is the first pod, right? Has 4 GPUs. Remember? So you can see here we have 4 GPUs. So it's telling you how much wattage it's using. It's not actually creating on climate change at the moment, but you can see here the memory is using around 20 gigabytes, right? It's already using all the memory with KV caches and loading the model, but there's only 4 GPUs, right? On the pod number 0. And if I do array status on my array cluster, so you can see the cool thing here, the array thinks it has 8 GPUs, right? And that's the beauty of the pipeline parallelism. The array cluster thinks I have 8 GPUs as a single unit. They are distributed across 2 machines. Those machines are cheaper, they are more highly available, they are not X200s, they are L4, which is very old model of NVIDIA GPUs, so they are more available, right? So you can run your workload with more resilience as well at cheaper prices, but you are loading the model across machines. So you can see I have this here, right? So what we can do here is, so let's see, I have 2 pods here. And I have a proxy running for my model here. I'm going to run some parallel client. This is running multiple requests. Hold on. So it runs all these requests to my Llama model. So like ChatGPT, all these questions that you can see on the screen has been sent to my model here, right? So you'll see after a few seconds, it will start to scale up, right? So let's see what's doing at the moment. So these are the Prometheus metrics that we have, and we keep on running. You'll find out it actually goes all the way up because I put all the requests, and will start scaling up. You can see already start scaling. So originally there were 2 pods, right? For one leader worker, and the leader worker, VLLM1, another one, 4-1, 2-1. So all this, it is scaling the pods as a sets. Because understand now? So not single pod, but as whole set. 2 pod, 3 pod, 4 pod, whatever, right? Based on that, it will load the model also and start serving the model from you. So you can see how it's already pending. So as soon as the machines become available via Carpenter, it will start serving the model. Take around 4 to 5 minutes to become active. So that way, you can load more models on a lower end hardware. You can have improved availability, and you can have better resiliency. Because imagine, even if you get, we have a hardware machine called P5. We got our P5 type EC2 incident. They're X100s. They are not even available to us because it's so much so less available. So how do we test the newer models? So there's always a challenge to get a P5. Like we have Slack channel, people say, hey, you got a P5, let me know so I can load the model for you, right? Because we prefer customers first, so they can get a P5 there. But with this approach, we can try the newer models as you go, right? So I want to show you one more thing here, and then I'll just shut it down. So I ran the Qwen3 coder model. So this model is 640 billion parameters. So I'm using 480 billion. It's a 480 billion model. It was released like 3 months ago. It's as good as Cloud Sonnet for your coding class, right? And I loaded them on, how many machines I loaded? Give me a second. Let me find out. Just 4 machines, right? Instead of finding 4 machines, right? And each machine has, don't tell my boss, I think it's increasing my bill a lot. So Each machine has 8 GPUs. So times 4. How many? 32 GPUs. Right? But I'm able to load it on a lower hardware, which is available to me now. So that's the difference. That's the benefit you can get from all these technologies that we talk about. All right. So I think that's about it. Any questions you have?
Do you have any performance data between what the difference would be running a distributed like this against one of those major machines? Like, what's your loss? What do you mean this?
Loss means in terms of latency?
Yes.
Okay. So you can see, for example, if you run in Bedrock, you can get, so in machine learning, you measure the latency with tokens per second. So we can easily hit throughput of 400 tokens per second with this. Yeah. It will never be as good as the other one, but it's good enough for running even the real-time inference. It's a bit slower, of course, because but still we can get around 400 plus tokens per second. That's a pretty good one to do.
Is that commensurate with the cost differences, or you're still far ahead because of the cost because you're running on old hardware?
Yes, it's cheaper. Cheaper compared to the running the latest hardware. Right, that's one. Plus there's opportunity cost, so we can't wait for the hardware available. But it's cheaper generally as compared to other models. Okay, any other question?
How much does this demo cost?
These are only 2G6 machines, so not a lot.
Not a lot.
Yeah.
Does it mean in your world?
So I think somebody has given a big bill, I think, right? So what is cost? One G6 performance machine is around $400 per week.
Oh,
Yeah, yeah. Only for 8 hours. I killed it down before I go home. Right? So $800. It's not huge. It's compared to if you're running S100, S300, S200, like D100, that's like $1,000. Yeah. But it's not cheap. It's still yeah, relatively cheap, yeah, but it is not cheap in absolute sense. That's what is all machine learning, because even though you have a good thing, for example, if I serve you in 2 seconds, but transaction cost is $20, you may be out of business, nobody will use it, right? So we have to take the balance at the moment. So we're learning how we can do that. Okay, any other question, guys? Okay, I'll give to Ram. Thanks a lot. Hey, sorry. Good, thank you.
Your Wi-Fi is the guest Wi-Fi?
Yes.
Can you repeat the?
The password is broken wire. And then at the rate 2019. Same password as
That looks almost complete. Anyone still signing in, looking for the Wi-Fi, having other technical difficulties? No, all good? Good? Gentlemen over there, you part of this meetup or? Just checking, all good. Yeah, just checking. All right, good, wonderful, anyone? All good? Last chance, raise your hand if there's any, or someone's still scanning. No, okay. All right, 15, that sounds about right. No, Gabriele, you cannot participate. But you can drop hints if you like. All right, then we're ready to go. All right. 4, 3, 1, here we go. First question, a technique to load a model across multiple GPUs on a single service called
Tensor parallelism.
Tensor parallelism, you know how to pronounce it.
Tensor parallelism, pipeline parallelism, multi-GPU loading and not post. Okay. Some
Almost,
mistake.
almost.
Next one, a technique to load a model across multiple machines is called tensor parallelism, pipeline parallelism. Oh, very important. Next one, leader worker set is logical extension of for which Kubernetes constructs stateful set, daemon set, deployment, replica set. Good. Next one. Scaling model serving across multiple machines have following benefits: performance, security, resiliency, none of the above. Right answer is resiliency. Amazon EFA provide low latency network connectivity across machines. True or false? Ah, Who owns CloudNativePG, CNPG? The PostgreSQL Global Development Group, Red Hat, EDB, the Cloud Native Computing Foundation, CNCF.
So Gabriele has 50% shares.
Good. What is the default replication method used by CloudNativePG for high availability? Storage level replication, PostgreSQL asynchronous streaming replication, PostgreSQL logical replication, PostgreSQL synchronous streaming replication with quorum. Okay, next question. Currently, FM2 is leading the board. Next question, what happens when the primary PostgreSQL instance is a CloudNativePG cluster fails? Cluster shuts down, manual intervention is required to promote standby. A standby is automatically promoted to primary. A new cluster is automatically created. Wow, but two more questions to go. In CloudNativePG, which custom resource is used to define a PostgreSQL cluster? cluster, Postgres instance, CNPG cluster, PostgreSQL cluster. Cluster. So FM2 is leading the board. One more questions to go. The last question. What storage approach does CloudNativePG use to persist PostgreSQL data? Stateful sets with PVCs, deployment with PVCs, customer controller managing PVCs, object storage volumes. Right answer is customer controller managing PVCs. Okay, FM2 is leading the board. He is going to be the first place. Let us in the quiz and go to leaderboard. So FM2 is the winner. So we have who is FM2? Pete.
Nice try.
Yeah. So we have 3 Code Cloud vouchers for 6 months. Then we have Akame Cloud voucher for 500 credits and Akame Exam voucher, which is of $2.99 voucher. Exam. So there are 3 prices. You can choose one. First one. Code Cloud. You need to.
Yes, then first have to come up. Still, most things. Then we take a little picture if you don't mind, and then I'll give you a link to.
Congratulations.
Yes, let's just go on social media. Sorry, you take the picture. Yeah, okay. Then use your phone. Yeah. So basically introduce you. And then there's a form, you just enter the details, you could just be on the speaker. Sure. Thank you.
Please, Matt Hertz. Matt, yeah, please come. So what do you choose? Yeah, please. Congratulations.
Same thing.
Rohan.
Work for EDB then.
Thank you. Do you choose which one?
First off, yeah. Thank you.
So we left with 1 Akame Cloud Access voucher with 500 credits and 3 certification exam with $1.99 for Akame exam. So next one is Balmik.
I'll go with my 500.
500.
The exam voucher?
Yeah. Not the exam.
The 500 we run out of.
No,
No?
the Akame Cloud Access.
Cloud Access, didn't we already have 3 of them?
No, I think you went for Cloud Access, right? Yeah.
Okay, also then we still have 1 left. Then so don't leave. You can just scan this form. Yeah. And then you default your details and select the one.
It's reflecting.
So
Thank you. Sam Hart. How many coming? Even.
Yeah, there is no one, so we've got. So
Congratulations.
Thank you very much.
So what is left out now?
left is. We still have the exam voucher, so there's still 3 left, and 2 of the book club. So you can choose either $99 exam voucher or the access for 6 months.
Am I allowed to take none?
Neither, if it's up to you, yeah, sure.
Realistically, I'm not gonna use it.
fair enough, that's cool. No worries, mate. Thank you. Yeah, that's all right.
Peter?
Ah, the usual.
Congratulations.
Thanks. We have a new form left. We still have.
Coming.
Akame $99. Come on. Yeah, okay, $99. My kids.
Ashish. One coming $99, right?
Yes.
The coming certification vouchers is alone. Coming. Certification voucher.
Then. Okay, backward.
All right. Next is left.
I am still good to the exam vouchers.
Okay.
Once it's a.
Okay. Cave.
Good cloud.
Component is all right. And they both let them choose.
What about the cloud?
Okay. Okay. That are only 2. Okay. You have cloud credits and 99 vouchers. One $1 and vouchers for common certifications.
That's the.
Coming certificate, coming cloud, right? Coming.
Come on.
Okay, yes, you. So remember. Can the cloud credit? Actually, no, they're already gone. There's no more cloud credit left. So we have either you can have either Echo and exam voucher. Okay.
Oh,
It's all right.
Yeah, that's it.
What is
Yeah, that's it, perfect.
Okay, thank you all. We can conclude our meetup today. Thank you once again for Gabriele and Faisal for the interesting topics today. And thank you for sponsoring us today, the event today. Thank you all. Thank you for coming and attending. And we have one more event. Basically, we usually take photo of all attendees and we'll post in LinkedIn. Yeah.
Hey guys, just one thing, take your rubbish with you, don't we? Yeah. Because we have to pay for the dates. Also, the lift will close at 8 PM sharp because of construction. So leave around 10:55. Otherwise, you have to go to B1, which I don't know where it is. Lift at 1, but I never.
Thank you.
That's what I think.